Hi everyone, and welcome to this joint webinar with Mathys and Squire, Hyperdrive, and the Northeastern Automotive Alliance. This webinar is on IP for the manufacturing and automotive age of change. My name is Julie, and I will be your host for this session.
Hi, Sean, can I just have the next slide, please? And then press it one more time for the video to play, please. Thank you. So hello everyone, I'm Rachel Skiak, Marketing and Communications Manager at Hyperdrive. So just to briefly introduce us, who we are and what we do. Hyperdrive was established back in 2012 and we design, develop as well as manufacture lithium-ion battery systems. These energy storage systems are used in a wide range of applications which range from construction diggers to material handling equipment, warehouse robots, as well as emergency response vans and even sports cars. We're based in Sunderland up in the northeast, and we're a specialist team of just over 45 people. Some of our customers include JCB, Northern Power Grid, the world's largest online grocery retailer, and just last month we signed an exclusive agreement with Hitachi Rail to develop battery packs to power zero emission trains, and also create a well-established battery hub up in the northeast. Hyperdrive is also home to Hive, which is the UK's largest independent battery pack manufacturing facility, where at our site in Sunderland we can manufacture up to 30,000 battery packs per year. And this is all to meet the growing customer demand for clean energy. I'm now going to hand you over to Stephen Irish, who is our founder and commercial director, who's going to introduce you to some of our IP. Thanks, Sean.
Thanks, Rachel. I thought it might be helpful just to start by explaining what we mean by IP and what it means to Hyperdrive and how we've been working with Mathys and Squire. So over the last few years, as Rachel has described, we've been developing battery systems. So we've got our own unique and proprietary designs around the battery management system, the battery packs, and the assembly methodology of those components. So we started very much as a kind of technology-focused company, and we've evolved into technology and manufacturing. I broadly break down the IP that is important to us in the kind of informal and the more formal, and so the bits that can't be protected around kind of know-how and trade secrets. So that would be the way, the kind of the design methodologies and the ways we've evolved, and the kind of knowledge base that we've built up, which is clearly very important and very valuable to us and our customers, but hard to protect. And then you've got the things on the right there, which clearly can be protected, so around copyright, registered designs and patents. So I'll let Sean and Andrew talk a bit more about those, but obviously copyrights are more or less automatic protections. That's quite valuable for us in terms of some of our things like firmware, where if people copied it, that would automatically be an infringement. But then we've also had a process of protecting the designs, so that the sort of the way the pack appears and it's constructed, and then some quite detailed patents around the things that go on inside the battery, so the electronics and the firmware and mechanical and electrical design. So if we can move on to the next slide, please, Sean. So why is it useful to us? It critically helps us and our customers get to market faster. So they're things that we've evolved, designs, capabilities over time. Obviously, if you're coming to all of this without that experience, it could take a long time to develop new technology. So having that backbone that we've invested in, it means that we can draw down on that experienced but also protected designs of particularly the electronics and the firmware, and deploy it really quickly. So it gives our customers and ourselves a competitive advantage, because it means we can get things into the market faster, but also speed advantage and a cost advantage, because you're not inventing things from scratch. Of course, the classic reason for wanting to have patents is to stop people from copying the products and the underlying technology. And some others which are perhaps slightly less obvious, we actually license some of our technology to quite large companies. A lot of work went into negotiating that and putting in the legal and commercial framework to achieve that. And it was really important for us to get the help we got from Mathys Squire to achieve that, to be really clear about what we owned. And then putting in the commercial structure which allows other people to use that technology. And that was a case where, you know, we favour manufacturing, but this was a case where the customer had a very clear strategy, and in fact already had a factory, and you know, they wanted to make this product themselves. So we came to an agreement. It was understood from early on in the project, and we came to an agreement about how we would help them develop their own version of the product, and we would license our background IP into them. That's ongoing now. And the last one there is perhaps something people have heard of in the UK, so other countries as well, but for us here, relevant because of the patent box scheme. So this is a means by which a pretty substantial tax advantage can be achieved if you sell product which has patents on it. I won't go too much into the detail, and it's quite complicated, but for us in future, we see that to be quite a substantial commercial advantage in future. It's a big reduction in the tax that you pay on the sales of the product that have patents on them. So if we go on to the next slide. I'm racing through these here, but by all means, at the end, if you have particular questions, please do raise them or take a note as you think of them. But to explain a little bit about how we've been working with Mathys Squire, so we're both members of the Automotive Alliance, but the relationship between the companies predates that. Been really helping us with a strategy of how we would approach our intellectual property and how we would protect it. And making sure that we've got a clear idea about what can and can't be protected, and really through a lot of those discussions, they've become a valuable sounding board for us. So it's critical, you know, as a technology and a manufacturing focused business, that you have access to skills and people with experience and knowledge in an area which is quite specialist. Sean and Andrew have really helped us with that. I touched on it earlier, but the next point is really ensuring, in particular, background IP, but also new IP that gets developed. So we talk about background IP as the intellectual property that exists prior to engaging with the customers or a new project, and that's really key, that you can be clear about what belongs to you before you start, so the waters don't get muddied as you go forward. It's easier said than done, perhaps. And then also how you deal with new intellectual property that's developed as a result of collaborative activities or activities with a customer. And typically, definitely more so on the types of technology and products that we've been developing ourselves, which we've spent some years in developing our battery systems, and they have a high level of functionality. Then you could expect there's quite a lot of new patentable feature, and the way we get to that is via a series of conversations, kind of workshop style activities, where our engineers talk through the functionality that we're delivering, and you know what the product's trying to do, and that's really valuable because it's not always obvious what can and should be protected. So I'll probably let Andrew and Sean comment on that later. But engineers and technologists tend to have a particular, you know, view, and you might think that you've got something extremely clever and some new inventive step, and it's not always the most obvious bit which can or should be protected for the technical, but also the commercial benefit it brings to the business. So that's been really useful. And then, of course, the very specialist activity of writing the patent applications and managing the whole process. So as you're turning those designs into the kind of legalese and the terrifying framework and that you have to navigate through in order to make sure you do it robustly, and forms of words which yes can be baffling at times, but is important to get right. So you can probably tell from the smiles my least favourite part, but you have to wade through them. So in summary, that's really why these things are important to us. We've had we were a startup in fact nearly 10 years ago, but 8 years ago we got our investment, and over that growth and the investment rounds we've been through, as I said, with that early sort of technology bias, and now to be making this stuff, this is really pertinent subject for us, and it's been very important from the perspective of how we're spending our investors' money, what we're doing with our shareholders' money, but also we're engaging with some really quite substantial international customers who want to know that we've been diligent, that we've invested the time and the effort in making sure that we've protected stuff, but also that we're not inadvertently infringing other people's activities. So that's all I was going to say for now, but happy to answer questions and interact with the next bit. I think we put this one in just here as in terms of the kind of deposition sessions, some of the ideas that we bring to might cause some head scratching for people to understand, and that's why you need people who know what they're looking at when you get into the detail of some of the engineering challenges and designs. So if anyone can protect that design, that would be impressive. Okay, so next slide. I think we're into Sean's part.
Thanks very much, Stephen. I'll have to come back to you on how to protect that last design. I was scratching my head over it last night. I'm not sure I've got an answer for you yet. Thanks very much for the introduction. My colleague Andrew White and I will talk through the next few slides, which we'll try to make as practical as possible. We'll explain a series of case studies based on real life cases that the two of us have worked on together, to illustrate a few points which I think are relevant to the types of businesses that we work with in the Northeast. Really, the case studies are about how to develop and manage an IP strategy to control IP risk that you're exposed to, and how to use IP risk to drive the decision making of your competitors, but also your commercial partners, to improve the commercial position that you find yourself in as a business.
So yeah, thanks, Sean. So I think one of the things we've been mindful of is your IP strategy should really be to add value to the business, and so that's something we've been doing for quite a while with Hyperdrive. We got in quite early with them when they were at a very early stage and growing, and we could take some quite simple steps early on to develop the IP strategy and help Hyperdrive achieve some of the commercial and business goals that they wanted to. So hopefully that's going to be reflected in some of these case studies we're going to run through now. And then we're going to just finish off with what we actually mean by an IP strategy. We're kind of aware that all of this is very familiar to us, and that some of it we may be banding jargon around. So it's quite useful, I think, sometimes just to see what an IP strategy might actually look like in practical terms. And then we're going to hand over to Paul afterwards to discuss the NEAA. So this is our first case study. So hopefully it's sort of simple and clear to understand. It's based on an anonymized real life example of working with a client. They're a manufacturing client, and we've been working with them for quite a few years. The MD who we work with, he was a very clever guy, an engineer, And as part of our work with this company, we had been performing some watching searches on their competitors, so he could be appraised on what the competitors were up to, what IP they were filing, to make sure that he could be up to speed and knew what was going on. We also helped invention harvesting or invention mining. So what we developed was what's called like an invention disclosure form that he would get some of his engineers to fill in and complete whenever they came up with something that they thought might be worthy of a patent. And this was to help the business stay innovative and to help sort of capture some of the IP that they were creating. And we would periodically catch up with him and go through the invention disclosure forms and make some decisions about whether him and us thought it was worthwhile filing patent applications directed to any of those ideas.
And Bill's view is that everything is obvious.
Exactly. So Bill, as his name was, he's an engineer, as I said, very clever guy, and to his eye, actually, most of the things the business were doing, as I said, they were a manufacturing business. They were incremental improvements or incremental developments on stuff they had already been doing, and he just thought, well, it's just simple, it's very obvious incremental development we've performed. And so Bill actually is making a conscious decision not to file patent applications or not to register IP for these incremental developments, because he thought he was limited, to cash. He couldn't spend all his money on IP all the time, and he thought actually the cost for registering the IP isn't worth the gain, because I don't think I'm going to have anything enforceable here. Now, as I said, one of the other services we were doing for this guy Bill was we were watching his competitors. And as part of that process, we were seeing there was a US company that was in the same space, that was his direct competitor, that kept filing loads of patent applications, and to Bill's surprise, they were getting granted. And he was pretty incredulous. He thought, how on earth can they get these patents granted to these things? To my mind, they're obvious. But I think what Bill was forgetting was he was a very skilled engineer in the field. So while it might be obvious to him, it might not be obvious to sort of someone else. Now, what was the relevance of these third-party rights that were getting granted was it was actually affecting Bill's decision-making process as to what the business was doing. It was affecting his decision-making as to whether they would invest in areas that the competitors were active in, whether they might expand into that same market, and or whether they might launch competing products. So actually, there was an asymmetry of risk here. There was Bill was actively deciding not to file IP himself, yet on the other hand, the competitor company, they were registering IP, and it was affecting Bill's decision-making process. So, we had quite a good relationship with Bill, and we flagged this to him in a sort of polite way, and eventually sort of twisted his arm and convinced him, why don't you just let us file some IP for your next product? Because
and he only let us do it because he was so annoyed with what the competition were getting away with, basically.
Exactly. So, we sat down with the engineers. We sort of just went away. It was quite a painless process. Got some patent applications filed, and they trundled on. It could take a few years to get patents granted, and Bill didn't really hear much, in the background. Eventually, we got the patents granted. He could use that for patent box tax relief, so that was great as well. But he didn't hear much else. A few years later, it actually turned out that our client, Bill's company, and the competitor became part of the same parent company. And so quite sensibly, all the parties sat down to think, right, let's go through all the assets we own, including the IP, and see if there's any sort of cost cutting we can make here. And really interestingly, Bill told us that the MD from the competitor company in the US came up to Bill and said, whatever you do, do not drop those patents that you got granted. They are in effect your crown jewels. They're what stopped us suing you and entering your market. Now, Bill, he had no idea that this had happened. He had no idea the effect his own IP had on the competitor's decision-making process. And so I think that's sort of the moral of the story here. Is in developing an IP strategy, it's all about risk management. You're always making decisions about IP risk, whether you decide to actively file or not, or whether you're doing something based on what your what other parties might have. And sometimes you may never know the effect that your IP may have on other parties, whether it's your customers or competitors.
I think that defensive deterrent effect of IP is one of the things that's most frequently overlooked by people who don't use the system. When you're faced with someone else's patent in a field that you're active in, what do you do about that? How do you clear the way? What do you do to control risk? And having your own patent doesn't free you from infringement risk, but it may very well reduce the likelihood that someone would take action against you. So it's about the pragmatic commercial things you can do to control the position you're in. I think that story is really, really interesting. It's an insight that I've only ever had once in my career. You very rarely see what the other guy is thinking in issues like this. Thanks, Andy. And that brings me on actually to another case study, which is similar in some ways, because it arose from a survey of IP that we did relating to a fairly mundane object. So this is a central heating pump. You've almost certainly got one like it in your house, and they're actually relatively sophisticated. There's an electric motor in that thing. The windings on the electric motor are put together quite carefully. There's an impeller in the pump housing that's quite carefully designed. And we were asked to review the IP in this product, and we came across a relatively large number of patent families. And interestingly, the most significant IP in this thing actually wasn't in any of the things that you might expect. So it wasn't that there were patents on the electric motor, there were patents on the winding, there were patents on the software, in fact, in that black control box on the side of it. But the most significant IP wasn't in any of those things. Actually, the most significant IP really was that black box which is stuck on the side of it. And when I mean the black box, I genuinely mean the box itself, not the electronics inside it. Because if you think about it, if you think about the circumstances of use of this product, what the customer demands, you've got to be able to fit this thing in the back of your closet, or in the space but beneath your floorboards, or under the stairs. Normally you fit these things in dark, inaccessible places to pipes which you cannot easily move. And what the arrangement of that black box enables you to do, it turns out, is route the power cable in from any of the four sides of that box. You can twist it round without changing the arrangement of the pump. You can twist it independently of the pump. And the control panel, which is on the front of it, you can orient independently of the arrangement of the power cable. And what that means, if you're a heating engineer and you've got to stick one of these things in the back of 10 closets in 10 different houses every day, is that you can program it easily once you've plugged it in. And it's apparently a nice, simple idea, and something which no doubt many engineers would write off as obvious. Entirely patentable, one of the most valuable patent families we came across in the survey of IP of this thing. And the reason I wanted to flag that is actually not entirely dissimilarly from the example we've just discussed. In attempting to clear this product, one of the patent families we decided we could not design around in trying to find a second source of supply for this thing, one of the patent families we decided we couldn't design around was that one relating to the routing of the power cable. So apparently very simple. Infringement immediately detectable. You look at that thing and you know whether it falls within the claim of a patent or not, right? And so the value of the IP was significant, but most significantly, it related to the customer requirement. It related to how the thing was used in practice. So the commercial demand here was, you have to be able to provide me with this function because the customer needs it. And really that I think is how people should be looking at the value of IP. It's not, patents in particular aren't a reward for technical excellence, right? No doubt all of your engineers are doing really complex, really detailed, technically very impressive work. And I don't intend to detract from the value of that at all. I'm not disparaging the value of that at all. but you need to think of those things independently from the commercial value of the IP, because the IP is a commercial tool. It's not about complexity. This inverse relationship, which I've put on screen now, is long established and very technically detailed. There is a directly inverse relationship between inventive step and commercial value. The things which are of the most value are those where there is the greatest market demand. So if you think about it, for example, putting a capacitive touchscreen on a mobile phone, apparently trivially obvious, of massive commercial value. Some very detailed, I don't know, AI algorithm which is buried down in some software somewhere, incredibly clever, very difficult to police, probably of less commercial value. High-level quantum computing, probably at present an invention before its time, incredibly complex, perhaps not the most valuable IP at the moment. So it's about understanding the position in the market and how the IP relates to the market. And so
I think it comes back to what Stephen was saying, is the IP that we might advise on protecting isn't necessarily what you may immediately think is, you know, the cleverest thing to protect. Actually, it's about aligning it with the commercial goals of your business and then trying to protect the IP that is closely aligned with those commercial goals and those commercial values.
Absolutely. So we have one more case study before we can hand over to Paul, and this is a set of commercial circumstances which we come across very frequently. Joint development projects between a customer and a supplier. So if you could imagine a customer who is has a market for a particular widget, they have a requirement spec for a particular widget, and they go to a technology company and they say, can you make us one of these? Let's say it's an electronic device with a PCB in it and some firmware on the PCB, a piece of consumer product that the end customer wants to sell. And if you think about it, in that product, there is, in terms of technology, there's some firmware and some source code, there's some electronics, there's some mechanical design of the thing, how you put it together, how you lay the components out on the PCB, there's the encapsulation, waterproofing perhaps, other things like that. And in each of those different aspects of the technology, there are different IP rights. So there's some copyright in the firmware, there's some confidential information in that and in the source code. There may be some patents. Likewise, in the electronics, there's some confidential information probably and some patents. And the mechanical design likewise, perhaps also some registered design there. So you can see in a fairly standard middle-of-the-road product, perhaps like a mobile phone or like a piece of electronics that you'd install in a car, there are a set of different IP rights. Now, let's imagine that our technology supplier has some background IP. They're experts in electronics and they're experts in firmware, and the customer has a requirement spec. This is a real-life example, and actually the circumstances are so common, I hesitate really to say how common, but very often people will conclude an NDA at the start of an agreement like this and then do very little else. They'll say, I've got an NDA, so my position is secure, and then before too long they get a purchase order for the supply of widgets or the manufacturer of widgets, and they think, great, I've made my sale, I can carry on. That's not really the whole story, because really the NDA isn't designed to be an IP agreement. It's not designed to apportion ownership of IP, and that's something that generally needs to be dealt with separately. In this particular case, what happened is that the original commercial relationship didn't end up as friendly as it began. And the two entities wanted to go their separate ways. The supplier found new customers that they wanted to take their ideas to fulfill new markets, and the customer wanted to go in their own direction and sell their product happily without having to be constrained by the supplier. Now, if you think about it, there's a whole bundle of IP rights which are overlapping here, cross-contaminated between the two. The technology supplier has some background IP in the electronics and in the firmware. The customer in the blue circle in our Venn diagram here, the customer had the requirements spec, right, which was covered by the NDA. So there are some rights and confidential information there which were binding on the technology supplier, and really the IP that was developed between them under that is in some way shared. They both owe corresponding obligations to each other. Their IP is mixed up in a difficult and unclear way. So actually untangling this problem was quite challenging, and there was a happy ending. We got to a position in which we had a clearly written definition of the respective technologies and respective IP rights, and we parceled up who owned what, and so they could each go their separate ways. But the amount of time and effort and cost, frankly, in untangling that mess at the end of the transaction was probably 10 or perhaps 100 times higher than the cost of a simple IP agreement would have been at the outset. So I think that the moral of this story really is that simple things done early will avoid big problems for you. I want to skip on. Go on, sorry.
I was just going to say, I think the reason the unpicking is so important, many people might think, well, does it matter? Why do I need to unpick these rights? We can just go on and do what we want. I think the reason the unpicking is so important is, if you're, say, a supplier supplying to an automotive manufacturer, you may have to provide a warranty as to infringement of third-party IP or ownership of the IP in the product that you're supplying. Likewise, if you're getting investment, you may have to provide warranties as to ownership of IP. You can't do that if you've got a situation like this where the boundaries are really unclear, and it may lead to you being dropped as a supplier, or you being dropped for investment. So that's why you need to unpick it. So that's why it's so important. And then
at the point they ask you to offer a knowledge-based warranty, the best position you'll normally negotiate is a knowledge-based warranty, right? We're not knowingly infringing anyone else's rights. If you've got this skeleton in your closet, you can't give even that. That's the point. Go on, sorry, I interrupted you. You done? Okay. So this Venn diagram is fuzzy and unclear, right? And Andy and I come at a question like this, and we begin to break it down. So we'll look at what's there in the technology, and we'll view things through the lens of the different IP rights which are present. And we do that because we're patent attorneys. This is our bread and butter, right? And it's the lens through which we see the world. Normal people don't think in this way. Okay, we look at a product and we go, all right, there's some registered design now, there's some copyright, there's some confidential information in the software, and so on. But it is useful, I think, to bring a little bit of that view into your business planning and your IP strategy, because really this is what we mean by an IP strategy. You understand the different threads of, frankly, property rights, the different assets that are involved in any particular project, and you make a plan for each one and you deal with them systematically. So the next slide is something that Andy developed. So I'll let him talk you through it.
And thanks, Sean. And it's very basic and very crude, but I think it just illustrates a simple point as to what we mean in practical terms by developing an IP strategy. And I think something we also are keen to highlight is it doesn't need to be costly, doesn't need to be complicated. What it means really is just taking sort of active decisions at the right time early on, so that things don't sort of get out of control or start, you have to fix them once the horse is bolted. So what we would typically advise when developing an IP strategy is to break it down into the different types of IP rights, whether that's patents, confidential information, as you can see here, and then think about what are the objectives that you want to achieve from the IP strategy. So whether it could be you want to maintain a supply agreement and so on. We've got a slide following on that highlights some potential objectives.
Do you want to skip on?
No, it's okay. Just hang on here. And then also, it's then identifying the IP risks associated with each of those rights. So it could be that for NDAs, right, you're aware that you've got NDAs in place, but then you could think in future, right, we need to action the NDAs. They're fine for now, but we may need to develop that into some kind of formal IP agreement if the relationship with that party improves in future. likewise with supply agreements with collaborators, you may need to consider having agreements in place with them. So it's really sort of breaking it down into different types of rights, thinking what are the risks here and what do we need to do in future to make sure that we can achieve the objectives we want it to achieve. And this is very much something that we would do with any business. We'd sit down and help them through this process. You don't need to do it alone. This is what we're here for. So if we do skip on the next slide. So just before we hand over to Paul, these are some common objectives that we encounter when working with clients as to what they want their IP strategy to do. Some of these are objectives that people didn't realize necessarily that your IP strategy can help you achieve. I think sometimes a lot of people we work with don't realize how effective your IP can be used to maintain a supply agreement with a customer. And I think that's something, Sean's experienced a lot before. People are just very surprised, and to us, very simple steps can be taken, patents can be filed to make sure that your customer doesn't go elsewhere or second source the product cheaper elsewhere. And there are some other ideas here. We'd be happy to take anyone through, as part of the NEAA, through developing an IP strategy and have an initial chat with you. And you just get in touch.
I think probably we should hand over to Paul at that point.
Thank you. Thank you, Sean, Andrew. It's, from my perspective, really insightful. And I particularly like the example of the heating pump. But I've also made a note around IP because we're entering into a number of projects now where we're putting NDAs in place, but not really giving any consideration around that IP. So I've no doubt I'll be having a conversation with you post this workshop. So if you just want to move on to the next slide, I'm just conscious there are a number of people on the webinar who don't really know a great deal about the North East Automotive Alliance and the industry here. So I'll just give you a quick update as to the background, but then wanted to move on and talk to you about some of the exciting opportunities that are happening here in the region. So in terms of the NEAA, we launched in 2015, quickly established ourselves as the largest automotive cluster in the UK with just over 270 members. But what's critical to the NEA is the fact we're industry-led. So Stephen, who you saw earlier, is one of my exec directors, a founder member, and sits on the advisory board. And through the NEA, we bring the industry together to work on common issues, challenges, where industry can gain an advantage through working on these issues collaboratively. We are very much an established automotive region, which is famed for vehicle assembly. And as part of our new strategy for the NEA, we're looking at how we can change that and really become a true automotive powerhouse and become that location of choice for automotive investment in Europe, building upon that solid base of being a truly globally competitive region for vehicle assembly, but really bringing much more R&D type activities here into the region, much more value add. And we do have a great base from which to grow. So you can see some of the key facts there with a very strong automotive base, 5 OEMs, 31 tier ones, UK's largest and most productive car plant in Nissan, 3 of the top 5 off-highway manufacturers based in the region, significant engine manufacturing capability, and the world-class supply chain. But as we move forward as a sector, we're facing a number of key challenges, and electrification is one of those. But within the North East, we do have a very strong base from which to grow. We're home to Europe's most successful electric vehicle, the Nissan Leaf. We're home to Europe's first ever gigafactory with the Envision facility, formerly Nissan's battery facility, and we're the only region in the UK that can claim to manufacture over 1 million electric motors per annum already. So we've got a great base from which we're looking to grow. Next slide, please, Sean. And in terms of how we do that, how we bring industries together, we typically work through a number of key thematic areas, 5 thematic areas around networking connectivity, bringing the network together, connecting members through events, marketing, promotion, etc. Addressing the skills issues and challenges we have within the region, supporting companies around trade and investment, helping companies in terms of business resilience and sharing the best practice, operational efficiency, and then the blue column on the left-hand side, which is around innovation and technology. And there's two key aspects of that. One is around the manufacturing technology we have, how we can help companies to automate and take advantage of digitization, but then also the on-vehicle side of things. Next slide, please, Sean. So just giving you a little bit more visibility on our strategy over the next few years. So as I say, we're really looking to transition the region into one that's famed not only for vehicle assembly, but has strengths in research and development. And that typically will be done through, in effect, three key challenges. Electrification on the left-hand side, and we've got a key initiative called Driving the Electric Revolution here in the UK, which is being led out to the northeast through the Beer Centre Northeast. Connected autonomous mobility, and we've got a programme on automated logistics, which I'll touch on shortly. And then the huge opportunity that industrial digitalisation presents. We're looking at how we can really strengthen the region and take industry challenges into academic, which will drive that academic research and really pull together some quite key, significant national programs around those three key themes. That will help us as a region really expand our capability. It should attract more investment, but it also will help companies de-risk innovation and should increase the public sector match coming in to support those activities. So what I'd like to do is just very quickly give you an insight into two of those projects that we're working on at the moment. So next slide, please, Sean. And then again, if you could. So EV North is the initiative we've launched to really look at how the Northeast can take advantage of the opportunity, the commercial opportunity that electrification presents. So if you think about the growth within electrification, in terms of power electronics, machines and drives, we expect the sector to grow by about 5 billion in the UK by 2025. Largely driven by automotive, but other sectors are also interested in electrification. By 2050, a conservative estimate is that the growth in that sector will be at around 80 billion just in the UK. And that is driven by obviously automotive, but other sectors like marine, aerospace, robotics, rail, energy, and a few others. So it's a huge opportunity that we can capitalise on as a region in terms of automotive, but also allow companies in the region who are operating in this area to expand their portfolio and operate in other sectors. So it's really about how we come together and position the Northeast as a global centre for design, development, manufacture of electrified powertrain technologies. We've got a strategy developed behind this of how industry is coming together, and as I say, we're very much industry driven, so we have an industry lead for this, and we've got various industrialists coming together to work on this strategy. But it really is looking at how we capitalise on that mega trend on electrification, how we build on existing regional assets and develop that capability and bring more RD&I type activities here into the region and grow those economic opportunities and really support that transition from that true to become a true automotive powerhouse and location for choice in automotive investment. Next slide, please. We won't do that alone. So the NEAA, in effect, we become the catalyst through which we can engage with the broader programs across the UK. Even for some of the largest organisations out there, it's very difficult to track where the best place or port of call is to address or to get support in particular areas. We work very closely with a broad range of stakeholders and can work with membership to make sure they're getting the best support from the excellent ecosystem we have across the UK. And vice versa, will be that gateway for those organisations to engage with the Northeast automotive industry. some of the things we're looking to do, because electrification is going to be quite a lot of opportunity for businesses to attract public sector funding. So recently there's been an announcement around the Automotive Transformation Fund, which is £1 billion been set aside to allow companies in the UK to capitalise on this electrification opportunity. We envisage we'll be doing quite a bit of consortium building as companies respond to those challenges, and it's one of the key drivers that for forming the NEAA initially. I mean, I don't know if you want to comment, Stephen, about the experience previously of the North East in terms of attracting public sector funding, but we certainly had a poor reputation before the NEA came around.
Yeah, sure. I mean, it's something that Hyperdrive certainly benefited from. We actually started with an Innovate UK Smart Grant, and then had success, including quite a substantial joint project with Nissan. So yeah, having that awareness of the types of competitions and funding available, and the rules, but also critically forming that those consortiums, so making sure people talking to each other and putting ideas together, and supporting that networking activity to pull the consortiums together is a key role for the Automotive Alliance.
Thank you. And it very much fits as part of the national government strategy. They're really pushing to try and make sure we grow the capabilities across the UK automotive sector, so we can retain more products or more supply chain from within the UK, which helps when we start to look at some of the issues that Brexit bring around as well. So another initiative I just wanted to highlight, if you just want to move on to one more slide, please, Sean, is a project that we've recently been successful in securing 4.8 million. It's a 4.8 million project, and it's about 2.5 million of funding through the public sector. And this is really to look at how we can develop a pilot and proof of concept around autonomous logistics delivery between Nissan and one of their key suppliers in terms of Vantec, who do the last mile logistics. So in the bottom right hand corner you can see a green line. The bottom building is Vantec, and they've got a private road access into Nissan, and currently do at around 100 deliveries a day. Nissan, as part of their strategy going forward, they've developed and implemented AGVs, automated guided vehicles, within the plant. They've expanded that to outdoor AGVs, moving product between the various parts of the plant. And the next key innovation challenge for their last mile logistics was to look at the automation of a HGV. So this proof of concept will take a 40-ton HGV vehicle, and we will deliver autonomously between those two buildings. There's an immediate opportunity there to look at then deploying that into other areas across the Nissan facility, but then expanding that just into the 7 other suppliers who are located within 2 miles, doing approximately 700 deliveries a day into the plant. So there's a huge opportunity for not only driving operational efficiency and effectiveness and competitiveness, but really there's a huge market opportunity to automate logistics, and it's certainly something that is high on the government agenda when you consider COVID recovery. People are talking about zero-touch logistics, minimising touch points within the logistics and supply chains, and they say this is quite a key project. This will hopefully then be the catalyst of some of the development of a globally unique test facility for connected and autonomous logistics. And if you just want to move on to the next slide there, please, Sean. So the proof of concept is the first phase of a multi-phase development strategy we have for connected and autonomous logistics. We're working with some of the key organisations. If you click once again, Sean, I think the logos will pop up there. With such as Zenzik, Made Smarter UKRI, looking at how we can develop this, deploy it into multiple routes, establish the test bed, broaden the 5G element of that, and then expand onto public road trials and autonomous logistics. We see this as being quite a key opportunity now. And just on this initial proof of concept, we've got several organisations, SMEs, who are developing the vehicle telematics, because we're taking out the need for a driver within the vehicle as we're doing the testing, and it'll be operated remotely. And that obviously brings with it issues around cybersecurity. We'll be retrofitting existing vehicle fleet with this autonomous technology. So I can imagine just on those two projects that I've highlighted there, in terms of electrification and in terms of the autonomous logistics, there's going to be an awful lot of requirement for IP as we really push forward and establish the region for these type of technologies. And that's not even taking into account some of the activities we're looking to do around industrial digitalization. So that's just a quick canter through in terms of the NEAA, the size of the organization, and some of the key things that I think are aligned to this webinar in terms of what we're doing to progress the region and take the automotive sector forward. I think that's the last slide, yeah.
Great. So I think that kind of concludes today's session. So thank you very much to all of our speakers for the wonderful presentation. I would like to take this opportunity to thank everyone who joined us online, and we hope you found this session somewhat useful. On your screens, next slide, please, Sean. On your screens, you'll see everyone's contact details, so please feel free to email our speakers directly with any follow-up questions you may have. And yep, finally, I'd just like to say thank you again and take care. We hope to see you at one of our future webinars.
Thank you.
Thank you
Thanks,
all.
Julie.
Thanks, everyone.
Thank you.
Bye.